Hi everyone. Today we're going to be going over notes 6.1 and we've already talked about 6.1a, so we will call these ones 6.1b. All right, and what this one is we're still going to be using law of signs today. However, we're going to be talking about ambiguous cases. So we'll get going here on the examples as to what an ambiguous case can be. So if we go back to 6.1a or even 6.2, we're given information. So in today's notes, the information that we need to keep an eye on is if we're given two sides and an angle. So if we were given side, angle. All right. And what we need to pay attention to is if we notice that between the two sides I was given, if side A is less than side B, then there's going to be three possibilities. All right, so right now there's not too much information. We're kind of going at this a little bit different, but when we get the practice in, that's where it's going to be important. All right, so at first I'm going to just kind of lay it out there, and then the practice is where it's going to come full circle and let us understand what's going on here. All right, so ambiguous cases talk about the option of us having a one triangle, no triangle, or two triangles. All right, depending on the angle that was given to me now, I have to pay close attention to that angle. In fact, if I was given an acute angle, meaning it was less than 90 degrees, and the two sides that I was given, if the first side is less than the second side, so the side that matches with the angle I was given, if it is less than the other side, I potentially have three possibilities for my answers. I can have a one right triangle, no triangles, or two triangles. All right. And in order to label these, just to look at the triangles, so first of all, one right triangle. Pretty obvious, we got one right triangle. The no triangle option, if you were to follow this blue line here as I trace it, it shows it's stopping at this side A here. In fact, it's stopping so much so that that triangle can't even be finished, meaning the length of side A is not long enough to complete that triangle. So that is why there would be a no triangle option. In the third option for two triangles, we are looking at this triangle first, triangle ABC, this smaller one here. Okay, so for example, if I gave you angle A, which is in this corner, we would then know our side A here, followed by our side B or C, depending on what they gave us. And right now, since we're talking about B, we'll stick with B. So there's my first triangle in this option. The second triangle is telling us that we're still going to have the exact same angle A, because we were given that angle. And we're still going to have the exact same length B, so it's going to be here. And it's going to be this bigger triangle. So those are our two triangle options, either a smaller triangle, depending on the angles that I find, versus the bigger triangle, again, depending on the angles that I find. And there's a way to determine if you have a two triangle option, a no triangle option, and a one right triangle option. And calculators will be used for today's notes, so make sure you have that calculator handy. All right. Then there's some rules here that talk about how to build your triangle. For today's lesson, I don't necessarily build the triangles, but if you want to, these are the steps you are going to take. So whatever angle you are given, first you're just going to build a triangle like normal, just any triangle looking like this. Whatever angle we give to you is going to go in the left corner, bottom left corner. And then obviously we would also give you the length that pairs with it. So you would have an angle and a side. And then the other side that we gave you is going to represent this length here, the base of the triangle. So if you are someone that wants to draw those triangles out, by all means, you most certainly can. And then if we get into the idea of a two triangle scenario, all you would need to do is just drop it down like so, and you're working with this smaller triangle. You'll still have the same angle, the same opposite side, and then your base will change a little bit. Okay? So, we know how to solve for one triangle. The no triangle option is really easy. You guys will see how that works on our calculators, because our calculators will tell us there's no solution or there's an error of some sort. So those are fairly simple. It's the two triangle case that we need to pay attention to, and we'll get the practice in today. So if we want to check for two triangles, remember the ways in which we need to check, the opportunities that tell us, hey, we got to go in and double check. First of all, we would be given side-side angle. And then the other key feature we need to remember is that the angle I'm given, if it's less than 90 degrees, then that is why we need to check for two triangles. So on your test, on your homework, anything like that, first of all, the directions will be clear. They're going to tell you, is this one triangle, two triangles, or none? So that will tell you when you need to check. Otherwise, if it doesn't explicitly tell you when to check, you are going to look for these two things. Are you given two sides and an angle? And if you are, is that angle less than 90 degrees? And if so, we need to go in and check for two triangles. All right. So in order to check, we're going to find our angle B using law of sines. So that's going to go back to our first day of notes. Remembering that formula, again, it's on our formula sheet. When we find our angle B, it should come out to be an acute angle, meaning less than 90 degrees. Once we find that, we're going to subtract angle B from 180 degrees, because 180 is the total amount of degrees inside of a triangle. And then we're going to take that angle that we got, and if we can add the original angle to it and it's less than 180, we will have two triangles. Okay, again, all of these words right now is just going to be very complicated until we start working through some examples. So just for your record, keep this handy, as I will be using this in our examples here in just a second. And you'll see what I'm doing as we go through. All right. So let's start with example 1. Again, we're going to stay consistent throughout this chapter. So whenever we're talking about lengths, we want it to the nearest tenth. Angles, we want to the nearest degree. So keep that in mind. It's going to stay consistent throughout this chapter. So if you ever question that, it will be the same throughout. All right. So in question 1, I give you angle A is 43 degrees, side A is 81, and side B is 62 inches. All right. So take a look. We're given two sides. And we're given an angle, and just double check that angle is indeed less than 90 degrees. So I need to remind myself that yes, I will need to be checking for two triangles on this problem. All right. So let's start with our first step. If I were to build my triangle, this would be A. Actually, just to match my teacher notes here, ABC is how I labeled it. This will be 43 degrees, so then 81 will be that length, while side B is 62. All right. So seeing what we need, we're going to need angles, and we're going to need an additional side. So let's start with angles first, just like we did in law of sines. We have a matching set. We know our A's, so let's do law of sines for that reason. Always shoot for law of sines first, as it is much easier to work with if you have a pair. And then the other side length we know is B, so then I'm going to solve for angle B here. Once this is set up, I'm going to cross multiply. That gives me 62 sine of 43 equal to 81 sine B. Now we're trying to get B by itself. Before I can attack that sine, I now need to look at the 81 and get that out of there by dividing. Giving me 62 sine of 43 divided by 81 is now equal to sine B. And then remembering how to get angle B all by itself, we now need to do the inverse of sine 62 sine 43 divided by 81, and we should get angle B now, all by itself. Okay. From here, we can use the calculator. Again, be very, very cautious with your fractions. It's much easier if you use that fraction mode on your calculator. Otherwise, if you want to type it in exactly as you see it, just remember to add those extra sets of parentheses to tell your calculator the difference between your numerator versus your denominator. Okay. Also remember that your calculator likes to add parentheses when you type in signs or inverse signs, so don't forget that feature to close those parentheses off as well as you are working through that. Okay. And again, we're rounding to the nearest degree, so we should round and get 31 degrees for angle B. All right, so now I have this triangle that is forming. Before I go and solve the rest of the triangle, the only thing that's different in today's notes is we have to check for an ambiguous case. We need to check for a second triangle. So as soon as I know this degree measure, I'm going to go immediately into checking for a second. So I'm going to do that work over here on this side. I'm checking for a second triangle. And remembering from those steps above, I'm going to take 180 degrees, the total amount my triangle can equal. I'm going to subtract what I just found, which was 31 degrees. And that will give me 149. Okay. So right now this is telling me of my full triangle, if I subtract 31 degrees, which is only one angle, I should have 149 degrees left to represent the other two angles in my triangle, my second triangle. Okay. Well, I just so happen to know another degree measure that's going to be the exact same in my second triangle, which was that A value. So I'm going to add that back in, as I know that's going to be part of my triangle. And that's going to give me 192 degrees. Well, 192 is way too big. It's greater than, it's greater than, so that's what I should write. It's greater than 180 degrees, therefore this is not going to make a second triangle for me. So I am done checking and I can move forward solving that one triangle just like I did in 6.1a. All right, so again, we have 180. We subtract the angle we were given, which was 31 degrees. And that's telling me that 149 degrees is what's left over. Okay, so that would technically be my second triangle B value. I said that incorrectly earlier. That's actually going to be my second triangle's B value if I had a second triangle. So that's what I'm going to test. So this would be triangle 2 representing my B value if it actually existed. And if it existed, I would then add that A angle back in to check, is there any wiggle room for a third triangle to get me to 180? And there is not any wiggle room because 192 is bigger than 180. Therefore, there's no extra room for me to have a third angle. So this would not occur. Okay. So again, that 149 is representing your obtuse angle of the second triangle, if it existed. But in this case, it did not because it was too big with the other angle I was given. So now we can go back. And I just need to complete solving for the triangle I have originally. So I know I'm working with only one triangle. And the lengths or the information I am missing is angle B, which I just found was 31 degrees. I'm also missing angle C, which I will find here shortly, and also side length C as well. Okay, So let's start with angle C. I'm going to take the full triangle, 180 degrees, subtract what I know about that triangle, and that is going to give me 106 degrees. So there is my second piece of information I need to know. And again, now that I know my C angle, I can do law of sines using the information I knew prior with the matching sets. Don't use rounded values as much as you can. Over C. Cross multiplying. 81 sine of 106 equals C sine 43. Divide both sides by sine 43. Again, make sure your calculator is in degree mode. We have yet to use radians quite this year. And when I do that in the calculator, remember parentheses if you need to add those so your calculator can tell the difference. And we should get 114 rounded to the nearest 10th, 0.2. All right, so again, we have one triangle option. And my answers to that triangle is 31 degrees, 106 degrees, and 114.2 labeled as my C length. All right, so we're going to go ahead and try question 2 now. Again, we're testing for ambiguous cases, so remembering the steps. In question 2, this time I'm not given angle A, but the same rules apply. I'm still given two sides, and I'm still given an angle. In this case, my angle is 75 degrees, which is still less than 90 degrees, so I'm still going to have to check. All right. So I build my triangle, again labeling my first angle in the bottom left corner, 75 degrees. Across from that is my 51. I should label these for you guys. My apologies here. And then C will represent 71 across from angle C. Okay. Start with the basics. We know a matching set, so let's start with that. Law of sines. Sine of 75 over 51 equals, and the C is the other portion that I know, but I don't know the angle, so I'm going to keep it sine C over 71. Cross multiplying, 71 sine 75 equals 51 sine C. Dividing both sides by 51. And then I'm going to skip this step, but we're also going to take the inverse. After we divide by 51, we will then take the inverse. So I would be looking at sine inverse of 71 sine 75 over 51 equals C. All right, so I kind of did two steps in one there. Again, I saw I was going to have to do the inverse sine, so that is what I would end up with. Okay. From here, I can go straight into the calculator. On your calculator, it is going to tell you error or domain or no solution or something like that. Either way, it's going to come up with some issue. All right. More importantly, I want to explain why. If I were to type just the inside of this into my calculator, that would still give me the inverse sine, which I haven't taken care of yet, of 1.34 blah, 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 blah. Okay? What this is saying right now, we didn't necessarily talk about this last semester, but it's saying your sine value when your sine is 1.34. Now, if you just pause for a second and you think back to our unit circle, did we ever have a sine value or even a cosine value that was greater than 1? Okay, remember the unit circle, unit meaning 1. The biggest value we ever got around that entire circle, whether it was for cosine or sine, The only value that was the biggest one we got was 1. Okay, if you want to test the square root of 2 over 2, square root of 3 over 2, all of those are still going to be less than 1. So that being said, we know that on the unit circle, this can never be greater than 1. And the reason for that is because this is referring to the unit circle. So even if I didn't necessarily do this in the calculator and I saw right away that 1.34 was asking me where is sine 1.34 in the unit circle, I can remember that sine is never greater than 1 on the unit circle, therefore this will not happen, therefore there is no triangle. So if you ever get anything on your calculator that says error, more than likely when you are checking for these ambiguous cases, there would be a no triangle solution. All right. Make sure, of course, on your test that you are in that portion of the test where the directions specifically ask, are you in 1 triangle, 2 triangles, or no triangles? Because if you get an error in another section, chances are that one was incorrect. Chances are you might have typed something in wrong or something. All right. Again, practice these on your calculators. Don't just take my word for it. Make sure the calculator is telling you the same thing I tell you it should be saying. If not, please let us know and come ask us that question so we can figure that out. All right. So we did not have to check for a second triangle on that question because the first triangle didn't even exist. So we're going to do question 3 now. Same idea. We're given 2 sides, and one of those angles that we are given matches my side, and it just so happens to be less than 90 degrees. So I will need to check for a second triangle at some point in this problem. First thing, draw a triangle, label it. I keep doing that. I want B in the bottom right. That's just how I have it in my notes, so that's how I'm going to do it here. Angle A is 40 degrees. Opposite that is 54. Opposite of B is 62. All right. So I will tell you guys right now that we will have 2 triangles for this example, just so that we can foreshadow and give it to you guys early. But we just got to be patient and see how. Okay. First things first, take your matching pieces and solve for angle B. So we have a matching set, so let's use law of sines. Sine B over 62. Cross multiply. Oops, not there yet. 654 sine B, dividing both sides by 54. I'll write all of this out now for you guys since I skipped that last one. Okay, and then again, in order to get B all by itself, we want to do the inverse sine to both sides, which would cancel that sign for me on the right, leaving me with all of this inside those parentheses. All right. Go into the calculator, ask the calculator to do this math for you, and we should get, when we round to the nearest degree again, 48 degrees. Again, as soon as I know an angle, I'm going to go over and immediately check for a second triangle. So here's me checking for a second triangle. I don't know if one exists yet or not, so I'm going to start with 180. Subtract the angle I just found, which was 48. And again, this is going to tell me my new angle in my second triangle would have to be 132 degrees. And again, this would represent my second triangle B value. All right. So we're not there yet. We don't know if we have a second triangle or not. So if my second triangle existed, my angle B would have to be 132 degrees. So then I would add the original A, which I know has to be the same regardless, and that's going to give me 172 degrees. Between those two angles that I have in my new triangle, I have 172 degrees. So on this case, there is some wiggle room because I am still less than 180 degrees. Therefore, I know that my C value or my angle C has to work for this one as well. All right. And since we're on this page here, I know that the difference to get to 180 from 172 would have to be 8 degrees. Well, that is going to represent angle C. All right. Now pay close attention. This is my second triangle only. So I'm going to keep that separate from my triangle that I started with. So I get to solve one at a time. Once we know we have a second triangle to work with, we're going to come back to that. But for now, I'm going to go back to this triangle that I was solving originally, 48 degrees. I know that I have a B value of 48 degrees. If my B was 48, my A was 40, then I must have a C value. If I do that math and take 180 minus 48 minus 40, my C value for that one would be 92 degrees. Okay, again, this is just the first triangle. I haven't touched the second one yet. In order to find my C, my lowercase c for this triangle, I would do law of sines, again using the information that already matched, except I'm going to use sine 92 for my C portion. Cross multiply, 54 sine 92, dividing both sides by sine 40. And my little c, when I get into the calculator, is going to tell me that I have 84. And again, if we're rounding to the nearest tenth, this would be 84.0. So that is the answer to the first triangle. But I know I have a second triangle. So now I'm going to do basically the exact same thing, but for my second triangle. All right. So again, this is a new triangle. If I want to build it, I'd still have the same A value of 40 degrees, the same A across, which is 54, and the same B, which is 62. The only thing that changes now is I found my new B, which would be 132 degrees. So that's what I will label. My new C, the difference to get a C value up top would be 8 degrees, which I already found. So the only other thing I'm missing is my lowercase c, so I have to do the same thing, law of sines, using the same matching set for A, because remember A is staying the exact same throughout. This time for my sine C, I'm not going to use 92, I'm going to use 8 degrees because we're talking about a separate triangle from before. C sine 40 equals 54 sine 8. Dividing both sides and getting C equals 11.7 when we round. And there we have it. All right. Again, you could keep putting all the information. So on the first triangle, on the first triangle, you could say angle A is still 40 degrees, side A is 54, and then side B is 62. If you are someone that needs to write all of that out, that is fine. And then the same thing for the second triangle, you're going to have the exact same information. A is still 40 degrees. If you added all your angles up, you'd still get 180. B is still 62, and little a is still 54. So you still have the exact same given information from the beginning, It's just different information from us having two triangles. All right, much like that picture at the beginning. So we're going to do question 4. All right, if you guys want to try this one on your own and pause the video and then come back to it to check your answers, you may. This is another two triangle question, so I want you guys to practice. You know it has to be two triangles, so make sure you're checking for a second triangle and confirming your A and B values and your C values. All right, so go ahead and pause if you'd like. And I'm going to go ahead and solve now. So again, we're given an angle, a side, and a side. The angle that was given was less than 90 degrees, so I am clear to keep going. Drawing my triangle, labeling it A, B, and C. 35 degrees for A, 12, and 16. All right. Start with the basics. I have a matching set, so I'm going to use law of sines and solve for angle B. Cross multiply gives me 16 sine 35 equals 12 sine B. Divide by 12 and inverse sine at the same time or soon after. Gives me B. When I use the calculator for this one, I should get 50 degrees for angle B. And once I know that, I go and I immediately check for a second triangle. Just so we don't get lost. The only reason we check here is so that we don't get lost in all of our information. So we do a quick check just to see, hey, am I going to have more work later, or am I going to be done after I solve? That is what we are doing here. So 180 minus the angle we just found gives me 130. Again, remember this is representing my new B value in my second triangle. If it exists, that 130 would represent my new B. So just to double check, see if it is going to exist, I'm going to add my original A to it to see if there is some room to find a C. So between those two angles, B and A, I have 165 degrees, which does confirm that I have a second triangle that exists. And I can quickly also just find the angle for C that will remain, which will give me 15 degrees. So I have that information. I know it's going to exist. I will come back to that here shortly. In the meantime, I'm going to go and I'm going to find my first triangle information. So I have a B of 50 degrees. I'm going to need my C value and my little c. So this would be 50 degrees. My little c, if I find that, would be 180 minus 50 minus 35, which would give me 95 degrees. And there we are. And then I go and I use my matching pieces again. Sine 35 over 12 equals sine 95 this time, because I'm solving for c. Cross multiply. Divide both sides by sine 35. And when I do that, my little c rounded to the nearest tenth becomes 20.8. So there's my first triangle. Second triangle, again, build it. We have A, B, C. A is still the same information, 35, 12, and little b is 16. But in this case, I now know my angle B is 130 degrees, making my angle C this time 15 degrees. Again, labeling my information as I receive it. So now I'm left with little c that I'm going to have to solve for, and I do law of sines again using the matching set. Again, we don't want to use the matching set with b here because b was an answer we had to find, whereas a was already given to us. That's really the only difference. Use what's given first before you have to use anything that was solved or rounded, if you can. And then when I solve for little c here, I'm going to get 5.4. And there we have it. There's our two triangles. All right. So tonight our homework is going to be, let me look it up here. It is something. We'll figure it out. Okay. On your homework, though, make sure you are checking for a second triangle. Again, the directions on your test, I'll review this again on the review on the study guide. The directions are going to specifically ask you, is it a 1 triangle, a 2 triangle, or a no triangle? If you see those directions listed, that means you will definitely need to start the checking procedure. Otherwise, if they're not listed, you don't necessarily need to check. But if you did, you would look for 2 sides and an angle that's less than 90 degrees. If that was given to you, that is the idea to go in and check.